You can increase your fuel economy by 10 to 20% or more just by trimming up the engine a little bit and running in the correct RPM range for your boat setup, if you have the correct propeller, that is. Whereas with the wrong propeller, it could be costing you hundreds of dollars every time you go out on the boat. There are tons of videos out there about propping and increasing your fuel economy, but I want to take this one from Ken Smith as an example to show you what I'm talking about. He was able to increase his mile per gallon by about 30% with just a prop change and at what speed he was running the engine, going from burning 16.44 gallons over 50 miles at 60 miles per hour to only burning 10.66 gallons over 50 miles, saving just under 20 bucks in a 50-mile run. So in order to explain how this kind of thing works, how you can take advantage of it and apply it to your boat, you kind of need to know how a propeller works. When you look at a propeller specs, you will usually see 4 out of the 7 main attributes of a propeller and how it affects the performance of your boat. You will see the diameter, the pitch, the number of blades, and the material that it is made out of. But you usually won't see anything about its rake, its cupping, the shaping, or the surface area of the blades, which are all super important things as well. Some of these attributes are self-explanatory and some not so much, but I'll put them all into understandably practical applications for you. The diameter of the prop is pretty easy. It's just how big around is the propeller when you measure it. The bigger around it is, the more water you're going to grip, and the more thrust or torque you're going to get out of the propeller. Though the bigger the propeller is, the more horsepower or lower unit gear reduction you're going to need in order to spin that bigger propeller. Not really the best for fuel economy or for speed, but better suited for moving a heavier boat. Then we have the pitch, which is the theoretical distance that the propeller will move through the water in one revolution. Always remember that it is theoretical because water is not a solid material and we have to account for slip, which we'll talk about in just a minute. And also the speed of the propeller will always be changing based on how you're running the engine. So a 17 pitch propeller will theoretically move a boat forward 17 inches in one revolution. And a 28 pitch prop will move the boat forward 28 inches in one revolution. Again, it's theoretical because of the other factors like the current weight of the boat, the current of the water that you're running in, how much wind is the boat fighting against as you're going forward. All these will play a factor in the true distance and travel that the boat is going to move forward in one revolution of the propeller. Sometimes a higher pitch propeller is smaller in diameter depending on the type of prop it is and its intended use. A higher pitch propeller like a 24 to a 34 pitch is usually applied best when top speed is the intended use of the boat, because the higher pitch usually comes at the loss of thrust and or torque, which is needed more when you're trying to move the weight of a heavier boat. But we'll get more into all of this when we talk about loading the engine or the propeller. The material of the prop is usually either aluminum, stainless steel, or bronze. Aluminum is a softer material that has give to it. So if say you hit something, the aluminum is usually going to either bend or break, which is going to help save your gear case from blowing up. Being the softer material though, they also have flex in them, which means over time and at high RPM, they can flex, which gives you a loss in efficiency and fuel economy. Whereas stainless steel is solid, though it's more expensive, it doesn't have any give to it. So if you hit something with a stainless steel propeller, you have a higher risk of messing up the gear case with the strike depending on the hub. But being harder, they give you better fuel economy and more efficiency. So if you run in deeper water, stainless is a great option. Whereas in shallow water or rivers where you run the risk of hitting something, aluminum might be the better option. Then bronze material is a strong, cheaper alternative, usually found on large inboard boats compared to outboards. They are popular on inboards because of their strength, the ability to repair them, their ease of maintenance, and the fact that they are a lot lighter than other options without adding cost. Now the number of blades will usually range from 2 to 5, 2 being most common in smaller engines like a 3 horsepower or a trolling motor, but not really that efficient when we're talking about an outboard with more horsepower, where 3 and 4 blades are the most common design. 3 blades have an advantage because they have less surface surface area, which means they have less drag, so they provide a certain level of efficiency and economical benefits. Where 4 blades will have more drag but will depend on the diameter and the pitch of the propeller. That's also why most 5 blades you would think would be slower, but most have a higher pitch and are designed mainly for either top speed and or sport applications. Think of a torque desiring application where you need a lot more torque or thrust, like a wake or ski boat, and for top speed, like a race boat. But this leaves 3 and 4 blades to be the most popular types for outboards. 4 blades with more surface area can give you more lift than a 3 blade, but a 3 blade can give you a higher top speed with a slower hole shot. Which brings us to the discussion and the importance of the other factors of the propeller, being the rake, the cupping, and the surface area or shape of the blade. The surface area is going to play more into the discussion of the 3 and 4 blade, but we need to understand the rake and the cupping first. Cupping is exactly what it sounds like. Think about cupping your hand. We can do the same thing with the propeller blade and cup it at different angles. When you cup your hand, you can scoop with it. So if we cup a prop blade, it gives us more scooping power, which provides us with more thrust and or torque by giving us more grip on the water. And ultimately, it will also increase the drag, depending. If we cup the prop blade in this direction, we will change the pitch of the prop. But if we cup the blade in this direction, we will change the rake. And the rake is basically the angle of the blade when we look at it from the side. Most propellers have a rake of about 15 degrees, though they can get up into the 30-degree range based on the application. When you look at it from the side, you will see that the blade is kind of curved backwards. Some of them might even be bent over a little bit, depending on the type of rake, and that is what rake is. Rake is important to understand because when you increase the rake, you increase drag and grip on the water. But at the same time, a higher rake usually means more bow lift. And with more bow lift on, say, a lighter boat that is built for speed, more rake is going to get more of the boat out of the water, which reduces the drag from the boat and increases your top speed. Just remember that more cupping creates more grip or more drag, which in turn makes them slower depending on the application. A heavier boat with a higher horsepower engine might need more cupping and more rake in order to give you better performance. Though most propellers that have a higher degree of rake are used for a higher performance application where the propeller is being run closer to the surface of the water. If you run a jack plate or trim your engine up a lot when running, having a larger rake or having that blade bent over backwards basically, when it gets to the top or the surface of the water, that rake helps it keep its grip on the water because it's cupped over, gripping the water. This makes it well suited for a large horsepower or speed application, whereas if you have an engine that doesn't need speed and you don't get close to the surface of the water, you have added grip that you might not need, which is going to be lessening your efficiency. More grip and more drag also means more load that is going to be put on the engine. The more load, the more fuel you are going to be burning. But before we talk about loading the engine, let's quickly talk about the blade's surface area now that you understand cupping and rake. Because when we start talking about the many different shapes and sizes of propeller blades, this is where we introduce prop slip, which might sound like a bad thing, but it's actually a good thing. Slip is basically the difference between the actual distance the propeller travels through the water compared to what our theoretical distance would be based on the pitch of the prop blade. And the surface area and shape of the blade is what's going to help change this actual distance of travel based on the application that the prop is being used for. That's why there are dozens of different styles of propellers with different shapes and sizes. Big rounded ear blades are going to be better suited for moving more weight. They don't have a ton of slip to them. Smaller pitches and larger diameters, which gives them a ton of grip. Smaller blades with more narrow surface areas and skinnier blades make them easier to spin so you can get more speed out of them, but you do lose your hole shot. And then say a cleaver prop that has 5 blades and a 38 pitch to it might have minimal cupping or rake. It might also have a super shallow angle of attack and might be used for a surface piercing race application, which makes it more of a custom build type of propeller. Seeing that those kinds of props are built and formed specifically for the boat and engine that they are going on, and that they are built for achieving top speed with a high pitch, high horsepower engine, and dialed in for the right amount of slip. Each prop is going to give you a specific performance aspect, and you can tell a lot about the prop just by looking at it, and then taking a look at what the manufacturer says that the prop is best designed for and for what application. Now, we mentioned angle of attack. The angle of attack is what makes the propeller work properly. If you don't have any angle of attack on the propeller blade, then you won't get any thrust out of the propeller. And probably the best way to describe the angle of attack is to think about it as the tilt of the propeller blade. With it tilted, you get an angle of attack. With that angle of attack, you get thrust and torque. Think about holding your hand out the car window. When you angle your hand up, you feel lift. In the terminology of physics, you are getting a negative pressure on one side and a positive pressure on the other. This pulls your hand up on one side and pushes it up on the other side. Same thing with the propeller. Negative pulling pressure on the front of the prop and then positive pushing pressure on the back, which is controlled by the tilt of the blade or the angle of attack of the propeller blade. And it's this angle of attack that gives us the thrust and the torque, but it is also what messes with the pitch of the propeller. And this is where we get slip. Again, slip is the difference between the actual distance of travel of the propeller compared to the theoretical distance of travel being the pitch of the propeller. The change in the angle of attack is what's going to change the actual distance that the propeller will move. So you do want some slip when it comes to the prop. Without any slip, that means no angle of attack, which means no thrust, no torque, no slip, and no movement. So the blade shape and surface area that we want is going to be determined by the desired outcome that we want from the prop. Now when it comes to talking about load though, it's pretty much exactly what it sounds like. Weight. The heavier the boat, the more load is going to be put on the engine. The bigger the diameter of the propeller, the more rake, the larger pitch, the more grip, and the more drag, all is going to increase the amount of load that is being put on the engine. This is important because when it comes to knowing if you are running the correct propeller on your boat, you now have an understanding of what the propeller is doing and what it is designed to do. And you can also identify what kind of prop you have. Also, with our video on why more horsepower doesn't equal more speed, you also understand what the gear case ratios mean. And just to remind you, the first number is how many times the engine spins around compared to how many times the propeller spins around. The bigger the first number is, the slower the propeller will be spinning, which is better suited for creating high thrust by spinning a larger diameter propeller. A smaller first number, a faster spinning propeller, better for speed and spinning a smaller diameter, higher pitch prop. Now let's go ahead and use Google to show you how you can figure out if you're running the correct propeller for your boat. All you need to do is Google the year, brand, and model of your boat looking for the weight. So if you have a 2004 Key West 1720, we'll look for 2004 Key West 1720 weight, and we'll get tons of different results. I would say to stick to the manufacturer or the actual brand website, or like JD Power or something like that. And that's because you can get different information from different sites and forums and stuff like that, depending on who it is that's giving out that information on the forum, though something like the weight of the boat should be pretty consistent. And now that you have the weight of the boat, think about how you use the boat. How many people do you usually take out? How much gear do you carry? How much fuel? How much water? Whatever. And guesstimate that number. Say if you take out 5 dudes at 200 pounds a piece, that's an extra 1,000 pounds plus say 500 pounds in gear and fuel. For us in our Key West, we're gonna add another 1,500 pounds to the weight of the boat, giving us a total of 2,650 pounds. Now back on Google, we're going to Google the year, brand, and model of the engine that you have. We have a 2004 Yamaha 92-stroke, so we'll look for a 2004 Yamaha 92-stroke RPM range. And again, try and stick with the actual manufacturer's website, but you should get a pretty consistent number even on the first page of Google. For us, we have a max of 5,500 RPM. This is a very important number because you want your engine to get to that top number or as close to it as possible when you're running the engine wide open throttle with the boat loaded down and weighted as you typically use the boat. This is where we get into the trimming topic though. If you have your engine trimmed or tucked all the way down, you will usually have negative trim, which simply means that the engine's propeller and lower unit are angled up or pointed towards the bottom of the boat. And with this angle, the propeller is actively forcing the boat down into the water, creating more drag, slowing you down, and costing you more fuel. It is also creating a heavier load on the engine, making the engine work harder and quote unquote slowing the engine down. But when we trim the engine up a little bit, we'll get the propeller to point down a little into the water, which is going to be positive trim. And just to clarify, positive and negative trim is just when we look at the outboard on the back of the boat. When it is completely vertical up and down, that is considered 0 degrees. And when we trim it down, that would be negative, and then when we trim the engine up, that would create positive trim. Most transoms already have a negative angle to them, so when you trim the engine all the way down, you will have a negative trim. So whether that be 5 degrees or 10 degrees or whatever it is, at least now you know what we're talking about. And when we get the propeller pointed down into the water, this actually pushes the boat up out of the water and brings our bow up. With more of the boat out of the water, this lessens the drag from the water, which lessens the load being put on the engine and actually lessens the force or work that the engine has to do, which is going to increase the engine RPM if we do not change the position of the throttle handle. So on your boat, when you get your wide open throttle number from your engine, remember if you got a trimmed or a tucked number. Trimmed having some positive trim to the engine, and tucked being the engine trimmed all the way down with that negative trim, creating a heavier load on the engine. Most dealerships will get these numbers and set up the boats with the engines fully tucked, because this means that there's more RPM available when the engine is trimmed up and they don't know how the boat is going to be used. Obviously, most people are going to load the boat down. So as the weight and the load of the boat goes up, the engine RPM that we're able to see and achieve is going to go down. So if they prop the boat with the engine tucked and get to the max RPM of the engine, hopefully when the boat owner loads it down, they'll still be able to achieve that max RPM number when they trim up the engine, which is basically how a boat and engine should be set up to run. But knowing all that you know about propellers now, just getting that number doesn't necessarily mean that that is the correct propeller for you and for your boat. Now you're going to need to go out in your boat and get that wide open throttle RPM number from your boat. And while you're out there, it's a good idea that you might as well go ahead and write down your top speed that you see as well. So now we have the weight of the boat, the max RPM number for the engine, and the actual RPM number that you see when you are wide open throttle in your boat. And you can look at your propeller and see what it is. Aluminum, stainless, 3-blade, 4-blade, what type of prop it is, and all that info. If you look at it, you will also see what pitch it has. Sometimes it will have a P behind the number, but other times it will just have two numbers, like a 13 by 17, which means it's a 13-inch diameter and a 17 pitch. We can actually use a couple more tools with these numbers now. The first being Mercury's prop slip calculator. Links will be in the description. Put your information in here and see how much slip you have. You want to be close to around 10% or so. Remember, you do want to have some slip, because it's what allows your prop to work properly. It's the difference between actual and theoretical travel, bringing us back to the pitch discussion and that theoretical distance that the prop will travel in one revolution. Again, you will want to be around, say, 10% to be more efficient. Now we can also use Mercury's prop selector as well, which is another useful tool to get you an idea of what type of propeller would be good for your situation based on what you are looking for. You can put all your data in here and see what the suggestions are for what type of propeller you could use on your boat, with options based on acceleration, fuel economy, top speed, and whatnot. But I want to get back to talking about load though, because it is what ultimately ties us back into how Ken was able to save so much on fuel economy, even though he does have an advantage having a Mercury engine. Some manufacturers like Mercury, Suzuki, and Honda have different forms of lean burn, which Mercury calls Advanced Range Optimization, or ARO. What that simply means is that the engine will advance the timing and cut back on the amount of fuel being delivered to the engine. Whenever certain parameters are met, like engine RPM, trim position, throttle position, O2 sensor data, and some other stuff, if the engine basically sees that you are cruising, it will go into ARO, or lean burn, which is going to drastically increase your fuel economy. And this is where sometimes, depending on the manufacturer and how they use lean burn, load is going to come into play. I guess the best way to say it is that if the engine is under too much of a load, it won't go into ARO or lean burn, because the engine needs the fuel to keep it where it thinks it needs to be based on the parameters that it is seeing with all of the stuff on the engine. So with the wrong propeller creating too much load and not getting your RPM right, you might not ever even get into the fuel savings if that engine has that ability, not to mention the trim angle. And hopefully by now you understand how you can increase your fuel economy with a specific amount of trim. And just on a side note, if you didn't know, since the computer is controlling everything when it comes to the fuel delivery, you might also see a difference in performance from the cold winter weather compared to the hot summer weather, because cold air is denser than hot air, resulting in more air molecules being put into the engine, where the computer can use charted temp graphs in order to apply more fuel into the cylinder and thus get you more power and torque out of the engine. So for some high performance people, they will actually have two different props, one for the summer and one for the winter, in order to take advantage of this performance. Now, even though all of this is also going to depend on your boat and its setup, the engine height, the water conditions and stuff like that, because you can also have too much trim too, where the boat is going to be losing speed or even porpoising. And finding the trim angle is pretty easy. Usually you just get to your cruising speed and then trim the engine up until you start to lose speed or the boat starts to porpoise. Then you just tap the trim down button a couple times until you get the speed back and the boat stops porpoising. And now you can decrease your engine RPM to get to whatever speed you want to run in, and usually, depending on your gauges, you can watch the fuel burn or fuel economy and see whether it increases or decreases. And then you will know where to run your boat based on that. And now you can take a look at your propeller and see what it is. How big around is it? How many blades does it have? Does it have a really low pitch? Does it have a lot of rake to it? And then you can also look at your top speed and what RPM are you seeing out of the engine at wide open throttle. If you aren't getting to that max RPM of the engine, then the prop is either too big around, the blades are too big, or the pitch is too high. And you are probably losing a ton of money even when you're cruising around because there is too much load being put on your engine. And it is burning a lot more fuel than it should even at cruising because the engine is overpropped, regardless if you ever run the engine at wide open throttle or not. Not to mention that overpropping the engine can be bad and cause internal damage if ran like that over an extended period of time. You're putting more load and more stress on the lower unit, the crank, and the rest of the internals of the engine when you're trying to get on plane, when you're trolling around, when you're in rough waters, even when you're at mid-range RPM. You aren't getting the horsepower out of the engine, and you're potentially shortening the lifespan of that engine.